Does Denmark's digital land registry need blockchain? The Danish land registration system, known as eIDAS, is widely regarded as the world's most advanced digital real estate system. Launched in 2009 after radical Big Bang centralization and digitalization effort, the system provides a fully electronic end-to-end experience for registering property rights. Its remarkable efficiency stems from a sophisticated architecture built on several key pillars. First, it's deeply integrated with other foundational public databases such as the Central Personal Register and the Central Business Register, allowing for unambiguous identification of all parties. Second, it achieves an automation rate approaching 90% with over 200 automated controls that allow routine transactions to be processed and registered in mere seconds. Third, the Danish state provides a comprehensive legal guarantee for the accuracy of the register, a feature so robust that has rendered private title insurance obsolete. Perhaps its most defining and revolutionary feature is the complete substitution of the traditional notary's role in the property transactions. This was achieved by mandating the use of Denmark's high-assurance national electronic ID, MitID, for all digital signatures. This system-based trust model, anchored in legally binding digital identification, fulfills and exceeds the traditional verification functions of a human notary. Given the context of deep digitization of the Danish land system, unparalleled efficiency, and state-backed legal certainty, the question arises: could a system that already represents the global pinnacle of digital land administration derive any meaningful benefit from the integration of blockchain technology? Hi, my name is Dr. Oleksiy Konashevich. You're on Blockchain State. Let's get a closer look at Denmark's land registry and blockchain. Digital experience and disintermediation. To understand the practical implications of Denmark's system, consider the typical workflow for a property transfer between two private individuals, Alice, the seller, and Bob, the buyer. The process is a model of digital efficiency that deliberately disintermediates traditional gatekeepers. While Alice and Bob can draft their own purchase agreement without a lawyer, this is the first distinguishing feature of the Danish system. As in many countries, a conveyance lawyer or a notary is a mandatory step of third-party involvement in private affairs. Nevertheless, it is customary in Denmark to engage a lawyer or a specialized agent to conduct due diligence and prepare the legal documents. Crucially, however, a notary public has almost no role in this standard workflow. The system's mandatory use of the national eID, MitID, for secure digital signatures makes the notary's traditional function of identity and intent verification redundant. The entire registration process is conducted online via the public portal Tinglysing. The users, Alice and Bob, or their representatives, log in with their personal MitID, fill out the required online forms, and pay the registration fee directly through the system. The critical step in the digital signing of the deed. Both Alice and Bob are prompted to sign the document using their MitID, an act that is the legal equivalent of a notarized signature. Once submitted, the deed undergoes a sophisticated two-tier verification process of the land registration court Tinglysing. Sorry, I don't know how to pronounce this. So basically, the land registration court. The land registration court actually keeps the register itself, the database. First, it goes through over 200 automated controls that validate the data against other public registers. For a standard transaction that passes these checks, the registration can be finalized as little as 5 seconds. However, every registration is still subject to a formal judicial examination. The system is designed to automatically flag any non-standard or complex cases, such as those with unusual legal text, for manual review by the court's legal staff. A process which typically takes a few days to a week, like a normal bureaucratic process in many countries. Upon successful registration, Bob's ownership is officially recorded, perfecting his title and protecting it against third parties. Services and API cases. The Danish digital land registration ecosystem is not a closed loop. It is explicitly designed to foster innovation by allowing third-party developers to build services on top of its infrastructure. The government formally provides two distinct tiers of access: a public API for searching and retrieving data, and a separate, more advanced system-to-system interface for approved professional entities to submit documents for registration. The public-facing property data tinglising API allows developers to create applications that can perform searches for property data, offering access in both XML and JSON formats. High-volume professional users, however, utilize the specialized system-to-system submission interfaces documented by the Land Registration Court. The financial sector uses the dedicated interface called eFPI to register mortgages automatically, while real estate agents and lawyers streamline data exchange through the eBollenhandel platform. Sorry if I pronounced it incorrectly. This API-driven approach means a third-party developer could create an integrated property sales portal for users like Alice and Bob. Such a web service could retrieve data, use the public search API to pull all public data about Alice's property to pre-fill forms and assist with due diligence, prepare documents, guide Alice and Bob through the creation of the digital deed, manage signatures, integrate with the eIDAS service to allow both parties to sign the document securely, submit for registration, use the professional system-to-system interface to send the signed deed directly to the land registry. Orchestrate payment. For a standard transaction, the portal would receive API confirmation of the successful registration within seconds. This confirmation could then trigger the automatic release of Bob's payment from an integrated escrow service to Alice, completing the entire transaction in a seamless end-to-end digital workflow. Denmark's commitment to open data and its advanced digital infrastructure provide all the necessary building blocks for a vibrant ecosystem of private sector innovation built upon the foundation of the public land registry. Blockchain and the Danish system, a solution in search of a problem. The following section presents typical skeptical opinions that are so common about the use of blockchain. In reality, as will be shown later, these are misconceptions that have sprouted and taken root in the expert community and require proper addressing. Misconception around trust, immutability, and disintermediation. It hypothesized that blockchain technology's primary value is in creating trust in environments where it is lacking. It offers a trustless system where a distributed network rather than a central authority validates transactions, providing a tamper-evident, immutable record. This is a powerful solution in jurisdictions with weak institutional trust or inefficient paper-based system. The Danish reality is the antithesis of this scenario. The system is built on an exceptionally high degree of public trust in state institutions, which, for unclear reasons, should always be assumed to be indestructible. The Land Registration Court is not a fallible intermediary to be eliminated. It's the source of legal authority and the guarantor of title. Replacing the legally accountable state entity with a distributed algorithmic system would represent a fundamental downgrade in legal certainty and recourse. Misconception on immutability. More so, true computational immutability is a bug, not a feature, in a legal system. Courts must have the ability to correct errors and enforce judgments. The Danish system has clear legal procedures for such rectifications, whereas a truly immutable ledger would make reversing a fraudulent transaction or fixing a simple clerical error operationally complex, if not impossible. The Danish system already provides exceptional data integrity, having operated without a significant crash or data failure since 2009, despite well-documented initial challenges at its launch. Misconception about digital identity. The Danish system has already achieved the most radical disintermediation relevant to this context by making the notary public redundant for property transfers. Their electronic signatures are based on the same or similar cryptography as blockchain. The blockchain is redundant, so. And since this was accomplished not with a blockchain but with a superior state-backed system of trust based on the national eID, MIT-ID, the blockchain would not create any added value to the system. By the way, I will not address this specific concern directly. Instead, I will explain what is wrong with the prevailing view on this issue. However, if you wish to delve deeper into how the European system of digital IDs and electronic signatures operates, and how the European eIDAS framework can be enhanced with blockchain, you can watch the two videos linked in the description below. Public versus private distributed ledger. A public permissionless blockchain like Ethereum is a non-starter for a national land registry due to its lack of privacy, volatile transaction costs, and slow speeds. A private, permissioned distributed ledger technology (DLT), where trusted entities like the court and major banks act as validator nodes, is more plausible, but ultimately pointless. It would be a complex and expensive way to build a distributed database among parties who already trust each other and are already efficiently integrated via APIs. In conclusion, the Danish Land Registry already delivers what blockchain promises in theory: near instant registration, robust security, transparency through public access, and a trusted record of title. It achieves these through a well-designed, centralized architecture built on a foundation of public trust, clean foundational data, and universally adopted digital identity. For Denmark, implementing blockchain would be a purely ideological exercise, offering non-tangible benefits over a system that already stands as a global benchmark for digital excellence. Interestingly, all these blockchain-opposing ideas were generated by the AI, Gemini in this instance, reflecting a collective opinion drawn from numerous academic papers that I have encountered over many years. I intentionally choose not to cite specific papers, as my goal isn't to pinpoint errors to any particular individual. In fact, these misconceptions are so widely repeated that it's challenging to identify their original source. Debunking blockchain misconception. Now let's debunk this myth. First, trustless correctly understood. A major misconception arises from the notion of a trustless system. In the context of blockchain's application in the public sector, such as a land registry, this concept is largely misunderstood. It is often interpreted as freedom from the need for a trusted authority to manage the system, suggesting that public registries on blockchain could become fully autonomous, requiring no authority. Initially, these ideas were spread by blockchain enthusiasts. Then, experts started examining them and inevitably came to conclusions about their flaws. However, the premise that when used for a land registry, blockchain requires no legal authority is a fallacy. And counter-arguments that disprove this hypothesis are irrelevant as they address a nonsensical concept in the first place. Satoshi Nakamoto never used the word trustless in the paper Bitcoin, a peer-to-peer electronic cash system, yet conceptualized a system that can be characterized as such. The paper explains a shared ledger that allows transactions with cryptocurrency in a distributed, decentralized network. In this context, the term trustless refers to the way the ledger, as a public repository, operates within such a network, specifically how the nodes that maintain the ledger synchronize. Cryptocurrency mining, in this essence, is an intricate method of synchronizing the ledger by procedurally agreeing on its correct version. It is this procedure of synchronization that is trustless. This says nothing about the necessity of a public authority in the land registration per se, but the fallacy is much deeper than this. Two levels: infrastructure versus application. A trustless network is an infrastructure for applications, like a land registry. The blockchain itself is not and cannot be the land registry. The land transactions cannot be a part of this ledger synchronization consensus procedure. The blockchain technology evolved from purely cryptocurrency applications to a sophisticated system for general user applications via so-called smart contracts. While any public permissionless blockchain fundamentally remains a system for cryptocurrency transactions, it became clear during early blockchain development that such an infrastructure is exceptionally robust and resilient to cyber attacks. This resilience allows users to secure unrelated data by attaching it to a transaction. Bitcoin enthusiasts developed various methods to secure data on the network, allowing many useful applications, from publishing messages, small images for fun, or creating so-called colored coins, the first decentralized finance digital tokens. This concept found a new approach with the advent of smart contracts on Ethereum. Nevertheless, publishing a smart contract is conceptually the same as publishing arbitrary data on Bitcoin. It is a way to secure a user application, the smart contract, that is not necessarily related to the underlying cryptocurrency transaction to publish it. In this model, the cryptocurrency, be it Bitcoin or Ether, is the gearing mechanism that enables a large, secure, and immutable public repository for arbitrary user data. The fee paid in cryptocurrency for publishing this data is an economic incentive for infrastructure providers, miners, to contribute their computational resources. Open competition in mining results in a practically impenetrable infrastructure, as seen with networks like Bitcoin and Ethereum. Bitcoin is arguably the most secure public digital repository ever created by humankind. While private networks protect themselves by being closed to unauthorized actors, public systems are inherently exposed. We often see reports on hacks of major infrastructure whose services are broadly exposed to the public, like Google, Facebook, Visa, MasterCard, you name it. Bitcoin stands apart in its resilience. As the only public system, and here I would stress the word public, not private, is the only public system that has not been ever compromised for over 17 years. A public permissionless blockchain such as Ethereum and even Bitcoin can be the technological foundation upon which a land registry is built. The blockchain is simply the infrastructure level, the database technology. It is not the registry itself. It is a digital storage medium for applications called smart contracts and their data. The land registry can be seen as a level 2 application, a smart contract, or more likely a set of smart contracts that sits on the infrastructure among many other applications. A parallel can be drawn with cloud computing. We do not identify an application with the Amazon Web Services cloud it runs on. The app could just as easily be deployed on, for example, Microsoft. This is the same level structure. Infrastructure like cloud, Amazon, and a cloud-based application. And trustless in the case of blockchain refers only to how multiple nodes communicate with each other to agree upon the correct version of the database to ensure the data integrity and consistency. That's it. It has nothing to do with the application. Why we still need public authority? Within the context of a blockchain-based land registry, trustless infrastructure can have only one implication. Among the range of duties held by the government agency responsible for the land registry, they now have at their disposal a robust public repository they can use as the database to operate property records. And doing so, they no longer need to maintain the network infrastructure themselves. This, however, would be a naive scenario just to illustrate the major shift in what the land authority no longer does as their duty. In the paper Cross-Blockchain Protocol for Public Registries, I explained the necessity to run a backup and to maintain a technical protocol. Nothing should be considered ultimate, even blockchain immutability. As discussed, the blockchain is a self-organized, trustless infrastructure whose operation creates immutable digital storage for general applications. The proposed protocol for public registries on blockchain conceptualizes all scenarios for the operation of a government registry on blockchain. Nevertheless, maintaining some technical protocols and ledger backup is not the same as the operation of the entire infrastructure. A typical land registry office has evolved through various technologies, from paper and fragile medium organized in physical archives with racks and folders to centralized electronic databases, which are also a medium whose data can be corrupted. Protecting such systems requires significant effort. Relief from the duty of being an immediate infrastructure provider doesn't mean the land registry office is absolved of its other functions. Registry and titling services differ from country to country in their level of bureaucracy and procedural complexity. The Danish experience shows that it is possible to dispense with notarization, a mandatory component in many countries. Registration for parties in real estate transactions in Denmark becomes fully digital, online, and almost seamless, all achieved without blockchain. Then why they still need the blockchain? To understand why the land registry still needs blockchain, even the existing Danish land system, it is critical to grasp the fundamental difference between an immutable, distributed public repository and a closed centralized database such as MySQL or any other similar database management system. Centralized databases are by their nature vulnerable to retrospective changes, both authorized or unauthorized, and even complete data erasure. Their architecture necessitates that they be closed systems with strict administrative access. In a land registry, a select group of authorized users, registrars, representing the public authority, are entrusted with recording title deeds. Just as paper registries were susceptible to tampering, the electronic register is intended to be an impartial third party safeguarding property archives. It is inherent to such technologies that only a limited number of authorized personnel can perform registry actions. Unrestricted public access would immediately compromise the register's integrity. If hypothetical individuals like Alice and Bob were granted direct access to make records, the database would have been exposed to the public and would undoubtedly face attacks. With a simple distributed denial of service attack capable of knocking it offline instantly. The severe threats of unauthorized changes and erasures are virtually impossible with the immutable blockchain. The Danish system, however, demonstrates that a centralized system can be accessible by users like Alice and Bob, but this is achieved through multiple layers of protection. Transactions are never published directly to the database. Alice and Bob do not directly interact with the registry database when they submit their title deed for registration. But their transaction undergoes a series of checks and verifications. Third-party providers seeking to build services via the Danish Registry's API must apply for authorization and are only admitted after thorough verification. Even the API documentation for search queries, which could potentially disclose the system's internal structure, is not publicly available. It is worth noting that a land registry DApp, decentralized application, consisting of a set of interconnected smart contracts running on a blockchain, would also have procedural and legal checks designed into it. Please note, in this context, a smart contract should be understood only as an application and should not be confused with a contract in the legal sense. The blockchain does not eliminate these steps, it only addresses the necessity for protective checks that shield the database from a cyber attack. Immutability is not a problem, but a solution. Blockchain technology can ensure data immutability, which practically means three things. Data cannot be altered, data cannot be deleted, and data is chronological. This immutability is not an inherent feature, but is achieved through the scaling of a public blockchain network. In its early stages, when the Bitcoin network's hash rate, a measure of network's scale, was small, the ledger faced a critical vulnerability. It happened the same year after the launch in 2008. However, as the network grew, such threats became practically impossible. While small, immature networks are susceptible to simple DDoS attacks, once they reach a certain scale, attacks like 51 attack become infeasible. Blockchain skeptics often argue that immutability is incompatible with legal purposes, suggesting that legal applications cannot be developed on a blockchain. This is maybe the most damaging fallacy of all, as immutability is the very reason why the technology must be used. Firstly, data in registries, whether paper-based or electronic, is never retrospectively changed. The standard procedure for addressing errors or changes in legal circumstances involves appending updates to previous records. Chronology is vital for maintaining validity, as it allows for the tracking of legal entries over time. A registrar wouldn't scrape ink off a paper document just as a previous entry remains intact in an electronic database. Any correction is always a new chronologically ordered entry. From this perspective, blockchain offers the ultimate solution for existing record keeping protocols because it not only preserves the archive but also ensures strict chronology, thereby maintaining indisputable legal validity. Its counterpart, a centralized, mutable database, cannot provide the same level of protection against retrospective data changes or the falsification of chronology. To clarify the origin of the misconception about immutability in the legal domain, it's important to understand its roots in cryptocurrency transactions. Immutability has always been a problem for cryptocurrency, as mistakenly spent or stolen coins cannot be reverted or returned through a retrospective transaction. This is a practical implication of the ledger immutability at the infrastructure level, where cryptocurrency's role is to ensure network operation through transaction fees, such as gas fees paid in Ether for smart contracts on Ethereum. However, this has nothing to do with the application level. At this level, the only problem with immutability arises from a poorly designed application. A smart contract for legal purposes must be built to accommodate the necessity of updating records as described earlier, and there are standard smart contracts that are designed for that. There are plenty of them. A land registry DApp, like any public sector application of a blockchain, requires an administration, the land authority, with the access to make changes by appending new records. In such a smart contract design, if a token represents a title right, a title token, the land administration must be able to burn any token in the registry, suspend, revoke, create, allocate, or reissue it, encompassing the full range of normal procedural legal actions required by a land registry protocol. Why no permissioned blockchain? There are a number of misconceptions about the use of so-called permissioned blockchains in the public sector. First of all, as per rigorous academic terminology, there cannot be a permissioned or private blockchain. It's an oxymoron, as blockchain, as the name of a specific technology, means permissionless public blockchain, as it was initially conceptualized by Satoshi Nakamoto and designed by Bitcoin's team. Not every chain of blocks is a blockchain. There is a crucial need to distinguish blockchain from the rest of distributed ledger technologies, which, depending on their features, are characterized as permissioned, private, or federated. Maybe there are some other names. The method of making a chain of blocks was invented by Haber and Stonetta in 1999. Nobody ever called it the blockchain. And what this method does is allow, by organizing data along with digital timestamps in blocks chained by hash sums, checksums, to check the validity of the data. The chain itself does not secure data from an authorized alteration or deletion. It's a method of data authentication, detecting forgery. What transforms a chain of blocks into a blockchain and thus enables it to protect data from unauthorized alteration in distributed networks is the open competitive consensus that is explained earlier, leads to data immutability once the network scales. The major difference is that permission DLT cannot achieve a comparable level of data protection, because first, they are centralized. Permissioned is a euphemism of centralized. And second, as they are hard to scale due to centralization. It is possible, but it's very costly. Often, distributed is confused with decentralized, which leads to the fallacy that a permissioned distributed ledger network is decentralized. It can be distributed, yet centralized, and permission DLT is exactly the case. Decentralized is a binary state. It it just means it's not centralized. No entity has authority over another, which is not true in typical permissioned DLT frameworks like Hyperledger or Corda. There can be varying degrees of centralization. For example, the right to issue and revoke certificates for public keys authorizing nodes in a permission network can be concentrated in the hands of an administration, of the network administration. Although nodes admitted to such a network may act as equals and synchronize on pseudo-competitive consensus using, for instance, a practical Byzantine fault tolerance consensus algorithm, and are decentralized among themselves, they remain under the full control of the network administration. A simple revocation of a certificate can remove any node, or even all nodes if needed. Such a network does not prevent retrospective changes and full deletion of the ledger. Thus, such a network will have a single point of failure and behaves as a centralized database. The scalability of such a network is limited by the need to control malicious behavior by the administrator, as nodes can be compromised. For example, the European blockchain services infrastructure, built with around 40 nodes, could be compromised by a cyber attack on 27 nodes. 2/3 of the nodes, which is not an insurmountable obstacle for an attacker to gain control over the consensus, especially when compared to thousands of independent mining nodes operating globally in networks like Bitcoin. Therefore, managing the administration of such a permission DLT presents a challenge, unlike the public network model where there is no need to manage the infrastructure. The practical implication of the closed nature of DLT networks is that users are not admitted to publishing transactions in the same way they do with a public blockchain. In DLT, transactions are first censored by the operating validating nodes, and after verification, these nodes publish them in the closed shared ledger. Such a DLT network cannot afford mere users to directly publish smart contracts and transactions, as an unlimited, undefined number of users simultaneously querying the network would pose a threat to its safety. The users of such a service are therefore detached from the database by validating nodes intermediaries. Thus, the network is never exposed to public interaction. A typical DLT will consist of a limited number of authorized and admitted nodes that provide various services, dealing with title tokens, operating digital dollars, stablecoins for payments, and so on. These nodes will establish their interaction through these shared ledger, distributed ledger. For users, such a service will resemble traditional centralized services provided by a single or several competitive commercial operators. The next section will explore how blockchain can break this vicious circle of constantly closed infrastructure and cartel-style market actors. Finally, it is often asked, who will be the validating nodes? This question can be addressed straightforwardly. In permission DLT, where maintenance of the closed infrastructure and hence authenticity, security of registry records, and control over the infrastructure can belong only to the land registry body. Unless statute law allows the land registry to delegate it to third parties, it wouldn't be legal for anyone else other than the land registry to run the permissioned DLT. In the case of the public permissionless blockchain, the answer would be no one, in the sense it is asked in permission DLT. In other words, this question is irrelevant for blockchain. As previously explained, nodes do not perform functions of the public, in this case land authority, and are detached from the user data that they operate. They archive the data in blocks, they let publish transactions, and take fees for providing such services. But the authoritative operation of the land register still lies with the land registry. Why the Danish system may still benefit from blockchain? In this technologically insightful conversation, one question is still pending. Why would the Danish system benefit from blockchain? Partially, the answer has been given in the section explaining the ability of the blockchain system to operate in an open manner where users like Alice and Bob, an undefined number of users, commit transactions with their property rights using smart contracts on the blockchain. This would be unheard of for a conventional centralized database or permission DLT, where only authorized operators must first be carefully selected and authorized for API access. Such operators become intermediaries that provide end-user services. And in the event of a cyber attack, the operator's server would be the first barrier to take the hit, while the database would be more likely remain intact, as the transaction reaches the server of the operator, not the registry database itself. These two levels, in reality more than two, protect the database, which can be so easily changed. To address the new possibilities such an open system brings, we should look at decentralized finance, DeFi industry on the blockchain. This emerging industry contrasts sharply with the conventional financial sector, which has been stagnant without innovation due to bureaucratic pressure. It should be noted that DeFi has, in a sense, gained a bad reputation due to fraud, money laundering, and other illegal activities. However, if we set this aside as a result of the slow development of adequate regulation, we see something far more valuable in all of this. This open architecture, not just open source in terms of code, specifically the openness of the blockchain infrastructure itself has become a catalyst for innovation. The new concept of a programmable economy and its derivatives, such as programmable money and assets, is a real breakthrough, where innovations are truly implemented, tested, and show excellent results. Skeptical remarks about cryptocurrency volatility and hence gas fees or privacy issues seems irrelevant and contrived, especially when one takes an empirical look at the development of DeFi. Did the high and volatile fees on the Ethereum network stop the industry? On the contrary, it spurred the creation of competing and cheaper blockchain systems like Solana, BNB, or Tron. In a situation where pseudonymity of the underlying blockchain technology is not suitable, there are zero-knowledge technologies. Blockchains have become the epicenters of innovation. Everything we know about this technology, all significant achievements and broad adoption, appear in open competitive systems. The progress in technological development and adoption of permissioned chains is almost unnoticeable. Nevertheless, the primary issue to be addressed is the challenge of designing a new system for public registries on the blockchain. It might seem that the proposed open architecture is simply unsuitable for a land registry. After all, the operators who are granted API access and authorized to provide registration and search services have undergone a vetting process for a reason. Wouldn't such an open architecture jeopardize the system itself? To answer this, one must understand that just because a blockchain system lacks the traditional concept of an API, it doesn't matter, it's impossible to properly organize such a registry. It simply means that reasonable restrictions must be implemented in the other ways. This will require a combination of several methods. First is the standardization of smart contracts. In my academic paper, I proposed so-called model smart contracts. In this system, only a pre-approved whitelist of smart contracts can be published and used by users. The nature of this approach is quite transparent. The code of these contracts can be fully open and published. Anyone can use it without needing authorization, like with APIs. Any attempt to modify the code and thus bypass the restrictions would be futile, as such a contract would be automatically rejected by the registry's base smart contract, the one that validates other contracts and transactions. Second, something that Denmark can be truly proud of is that all its validations are conducted online. Checks for identity and legal capacity, verification of encumbrances and title restrictions, and other verifications carried out in digital databases can be performed in the exact same way on a blockchain system. In case where data is stored on a central government server, an Oracle architecture is used. This is when a smart contract receives data from an authorized external source, while data already on the blockchain is validated instantly upon the contract's publication and execution. And fewer third-party oracles there are, the fewer bottlenecks such a system will have. Obviously, the concluding question to answer is how to implement such a system. There are many misconceptions surrounding this, such as the idea that the entire registry must be moved to the blockchain overnight. The argument follows that since a registry contains a certain number of errors, they would be transferred to the blockchain, where they would become impossible to correct. If that were true, a blockchain-based property registry would be impossible. This is a common line of reasoning among skeptics. However, as we already established, errors have never been the problem. A subsequent correcting transaction, by virtue of its strict chronological order, resolves the issue of which record is valid, the latest one. Nevertheless, the main point is that there is no need to abandon the old system right away. For example, in Australia, the old land system inherited from England operated in parallel with the new torrents system, which is very similar to the registry systems in continental Europe, for over 150 years, until a new law moved to abolish the old system by 1999. In the same way, a new, properly integrated, technologically, legally, blockchain system can operate alongside the old one. In this respect, Denmark is at the forefront, having deeply digitalized and debureaucratized all its real estate transactions. Only one step remains to implement a parallel blockchain system. In this system, an owner would have the choice either manage their property within the old framework or tokenize their property by creating a title token. This token would represent the ownership right, allowing them to perform economic actions with it using smart contracts, thereby realizing the enormous potential of the blockchain. In this sense, a parallel system is the best solution. In many countries, the land registry system isn't broken. It may be inefficient, slow, and bureaucratic, but it works. Abolishing it could create more problems than it solves. However, creating a competing parallel system where innovations are gradually implemented through careful development and testing makes enormous sense and holds great promise for the future. With the extension of economic and technological freedom thoroughly safeguarded by proper regulation and technological standards, new markets will arise and new forms of economic activities in the digital space will provide better user experience and investment opportunities. So that's it for today. I hope it was interesting. Hit like and subscribe. See you in the next one.